question asks us to draw a Newman projection of the given molecule, looking down the 2,3 bond, such that the bromine and hydrogen have a 180-degree dihedral angle. The first thing we need to do is draw an identical Newman projection of the molecule, and then see if we need to do any rotations to get the bromine and hydrogen to have a 180-degree dihedral angle. I've drawn our perspective eye looking down the molecule from the left side. When I look down the molecule from the left side, carbon 1 is down in the southern hemisphere attached to carbon 2. It's an in the plane bond, which means it will be on the vertical axis of our Newman projection. This will be carbon number 1. Carbon number 4 and 5 are in the northern hemisphere attached to carbon 3. They're in the plane of the molecule, so they'll also be on the vertical axis. That would make this carbon 4, and carbon 5 would be coming off of carbon 4. If I'm looking at the molecule from the left, this bromine atom is on the dash further away from me. Because it's on the dash further away from me, that means that it's going to be on my left-hand side when I look at my new Newman projection. Attached to carbon number 2 in the northern hemisphere, on the left-hand side, we'll have our bromine atom. The implied hydrogen is on a wedge on that same carbon. Because it's on a wedge, that means it'll be on the right side of my Newman projection. The hydrogen will go here. The methyl group is in the southern hemisphere of the molecule. It's attached to carbon 3. It's also on a wedge, so when I'm looking at it from the left side, because it's on a wedge, that means it'll be on the right side of my Newman projection. The methyl group will be here. And the final hydrogen is, if I'm looking at it from the left side, it'll be on a dash, which means it will be on my left side, and so that will be on the left side of the Newman projection here. This is an identical Newman projection for this molecule. The question asks us to have this bromine and this hydrogen have a 180-degree dihedral angle. Right now, they don't have a 180-degree dihedral angle. Right now, they have a 60-degree dihedral angle. So we'll need to rotate one of the carbons of this Newman projection to make it a 180-degree dihedral angle. So we'll redraw our Newman projection. I'll leave the front carbon the same. The bromine will be on the left. The hydrogen will be on the right. Carbon 1, carbon 2, carbon 3 is the atom we can't see in the Newman projection. And I'll rotate this back carbon to put the hydrogen 180 degrees opposed from the bromine. When I do that, the hydrogen will now be on the bottom right, the methyl group will be on top, and the ethyl group will be on the left side. This now gives the bromine and the hydrogen a 180-degree dihedral angle. This is the Newman projection that puts the bromine and hydrogen at a 180-degree dihedral angle.